Hey guys, welcome to Master and Learn It. In this video, we are going to be deriving the quadratic formula using completing the square. If you haven't subscribed to Master and Learn It, please do so. A quadratic equation of the form ax squared plus bx plus c is equal to 0 is used to derive the quadratic formula. The first step is to transpose all constant terms to the right hand side. A constant term is a term that does not involve x. So you can see that c is the constant term. We have ax squared plus bx is equal to transpose c becomes negative c. The following step is to divide the entire equation by the leading coefficient. Our leading coefficient being a. So I divide all the terms in the equation by the leading coefficient. A cancels a, we're left with x squared plus b over a x is equals to negative c all over a. The following step is to complete the square. So when we complete the square, we'll look at the coefficient of the second term. We halve it, then we square it. So the coefficient of the second term is b over a. We have to halve it, so I multiply by a half. Then we need to square it. Simplifying what is inside the bracket, we have b over 2a, and we square it. So we are going to replace this term to both sides of our equation so that it doesn't lose its value. I rewrite my left hand side having x squared plus b over ax. Replace this positive b over 2a squared is equal to, replace this to the right hand side, we have b over 2a squared. Bring down our constant, negative c all over a. From here we can see that our left hand side is a perfect square trinomial. So we can either factorize using our long method that we know, or we can factorize directly or by inspection. You can see that these two terms are squared. So I am going to take these terms that are squared. We have x and we have positive b over 2a, and they are all being squared. That's simple, right? Take the two terms that are squared, then you rewrite them and you square them. If this was a negative, this should have been a negative. We simplify our left hand side. Simplify b times b to the power of 2, we get b squared over 2 squared is 4, a squared remains a squared, minus c over a. The following step now is to simplify our right hand side. In other words, we just want to write this one as one fraction. So the one of the quickest method is to cross multiply. I'll cross multiply denominator times the numerator, denominator times the numerator, then denominator times the denominator. So I rewrite my left hand side, x plus b over 2a squared is equals to a times b squared, ab squared. 4a squared times c, we have negative 4a squared c. Multiply your denominators, we get 4a squared times a, that's 4a cubed. Now let's factorize our right hand side, because you can see on our numerator we have a common factor of a. So let's just take out the highest common factor. Rewriting my left hand side is equal to highest common factor a, we divide a into ab squared. So a cancels a, we're left with b squared. A cancels a, so we're left, a cancels a squared, so we're left with a. So I have negative 4ac all over 4a cubed. Now we can simplify. A can cancel a cubed. A cancels a cubed, we're left with a squared. Rewriting our expression, we now have x plus b over 2a squared is equals to b squared minus 4ac all over 4a squared. I'm sure by now you can see the direction of where our sum is going towards. I'm sure you've identified that this is becoming the quadratic formula that we all know. The next step right now is to make sure we clear off these brackets. So I need to square root both sides so that I can remove this square root. I can remove this square. So I'm going to square root both sides. And when you square root on your left hand side, you must imply a plus and a minus. Don't forget to put a plus or a minus. The reason why, because the square root of 4 could be plus 2 or could be negative 2. Because negative 2 times negative 2 would still give us 4. 2 times 2 would give us 4. So imply a plus or a minus on the right hand side. The square root will cancel off with 2. So we are left with x plus b over 2a is equals to, the square root of b squared we know is b, of 4 is 2, but we don't know of a and c. So I'm going to rewrite this as it is. Remember, we have our plus or minus b squared minus 4ac. But I know the square root of 4 is 2. And the square root of a squared is a. Let us leave x alone because we want to find x. So I'm going to transpose everything to the right and leave x on the left. So this is x is equals to, sorry, let me just go a little bit down. X is equals to, transpose, we get minus b over 2a. Remember, when everything is transposed to the other side, the sign changes. Plus or minus the square root of b squared minus 4ac all over 2a. What do you notice? We do have two fractions, and these fractions have the same denominator, right? So if fractions have the same denominator, it can be written as one fraction. If we have 1 over 3 plus 4 over 3, this can be written as 1 plus 4 all over the same denominator 3. So this is what we are going to do. So x is equals to minus b plus or minus the square root of b squared minus 4ac. And all these fractions are written all over 2a. There you go. You would have derived your quadratic formula using the completing the square. We can also use in completing the square on a quadratic expression that is not an equation. Suppose you just have this expression without equal to 0. So in the next video, watch out how we can complete the square on a quadratic expression, not an equation, and to see how we can use the quadratic expression to derive the minimum and the maximum value. Thanks for watching.